Okay, this is a continuation of section 1.5, MAC1105, and we were on the last problem where we were trying to clear out the fractions and then decide what we're going to use as a method for solving the type of equation that results. So I had broken down this denominator just to see if there was anything new when we any new factors that aren't being seen here and here, because you need to throw in each different factor that you see. You need to throw in one of each different factor, unless they're the factor you have factors that have higher powers, then you need to throw it in to that higher power. We are not presented with problems like that. So there are two different factors happening here. Nothing new happened here, because when I broke this x squared minus 25 down by factoring, all it resulted in is factors that I'm already seeing here and here. So as far as unique factors, we have an x minus 5, and we have an x plus 5, and then there were no new factors here, and nothing unique that hadn't already happened. So this is going to be our LCD. We're going to multiply every single one of these terms, and whether they're fractions or not, you multiply them by the LCD. So here's my LCD in front of the first term, just so you can have a visual of what cancels. Here it is again. And then here it is again. Okay, each time something's going to cancel, and what remains will be dropped down into the equation. So in this first product, when you're multiplying all of this times all of this, the x minus 5's cancel, leaving you with 2x times x plus 5. In the second product, when you're multiplying this whole LCD times 3 over x plus 5, the x plus 5's cancel, leaving you with 3 times x minus 5. Bring that plus sign down. 3 times x minus 5. Then when you multiply the LCD times the fraction on the right-hand side, all of this cancels with this entire LCD, leaving you with just negative 21. Okay, now you have no fractions, but you're going to remove the parentheses, and that's where you're going to create a quadratic equation, which of course is the emphasis of this section. So you're going to have 2x squared, because when you're multiplying, of course, you add the powers. Excuse me. And then 2x times 5, that's going to give you 10x when you do that. Distributing the 3 to this next parenthesis, that would be 3x, and then 3 times negative 5 would be negative 15, is equal to negative 21. So now you've gotten rid of the parentheses. You're going to bring everything to one side, because you're most likely going to either do factoring or you're going to do the quadratic formula. You can use other methods if they apply. Okay, so when I bring this over here, it becomes positive 21. That gives you 2x squared. When you combine those x's, you have 13x. And when you combine these constants, since the negative 21 is now over here presenting as a positive 21, you have positive 6. You can try and factor it. If you are going to factor it, you would be using either guess and check. These are methods for trinomials, quadratic trinomials, or you could use splitting the middle term, either one. Okay, now since this is a pretty small coefficient, let's try guess and check. When you're doing guess and check, you have to use the process of foiling while in the middle of the problem to see if you've placed the numbers properly. Okay, placement of what goes in the front position of each one, you're breaking up this squared term to go here and here. So the only way you can break this up to dissolve the squared term is to go 2x times x. Okay, then when you go to fill in the back position of each of these parentheses, you're breaking up the last term. So how can you break that up? Well, you have options, which is why it's called guess and check. You're going to either guess that it's 6 and 1 And that 6 could be here or it could be here. So there's an element of guessing there. Again, how good you are at the guessing part is basically related to how good you are of visually, mentally being able to FOIL. You could also try the 3-2 combination. 3 times 2 is 6. So it could be a 3 here and a 2 here, or a 2 here and a 3 here. Now, I see that I'm going for a 13, and I'm already thinking about mentally the foiling process, that if I put a 6 here and a 1 here, I'm going to get 13 because I'm thinking of the foiling process. I'm thinking to myself, okay, well, if I went 2x times 6, that would give me 12x, and I could get another x right in there to give me 13x. So I'm really thinking about the foiling process before I commit to where I have placed these things. When the last term is positive, both of these will be the same sign, and this is what they'll both be. So through guess and check, that's how I chose to factor this. Okay, I'm going to check it real quick. 2x times x, 2x squared. 2x times 6, 12x, plus another 1x would be 13x. And then that last term times last term gives you that. Everything checks out. I have factored it properly. And then to actually get the solutions that go with it, you create linear equations out of your two factors. So from this factor, I get the equation 2x plus 1. And then from the other factor, I get x plus 6 equal to 0. So I'm going to bring this over here, and then I'll have 2x is equal to negative 1. And then divide by 2, and I get x is equal to negative 1/2. Then here, bring this 6 over here, and you get x is equal to negative 6. So you have one answer here, one answer here. You can put it in a solution set if you like, just, depending on what they're asking for. Or you can just list them separately, separated by commas. And those are your two solutions. That completes 4 different techniques for solving second-degree equations, which are called quadratic equations.